Hello students, welcome to Educate. In the last video, we have discussed about Raoult's law, about the concept as well as in-text question. In this video, we will discuss about ideal and non-ideal solution. As there is ideal gas and non-ideal gas, that means real gas. In the same way, there is ideal solution and non-ideal solution. What we have studied about ideal gas, which obeys gas law. In the same way here, for the liquid in liquid solutions, law is Raoult's law. So, ideal solution will be the solution which obeys Raoult's law over entire range of concentration. So, ideal solution is the solution which obeys Raoult's law over entire range of concentration. And the characteristic of ideal solution is delta H mixing equal to 0 and delta V mixing equal to 0. The characteristic of ideal solution is delta H mixing equal to 0 and delta V mixing equal to 0. What's it meaning? Let's see. There is a liquid component, liquid here. Its volume is 1 liter. And there is another liquid. There is liquid A whose volume is 1 liter. And there is another liquid whose volume is, suppose, 1.5 liter. There is liquid B whose volume is 1.5 liter. When you mix both the liquid, then the volume of the resulting solution should be 2.5 liter. Exactly 2.5 liter. When A and B will mix together, the total volume of the resulting solution will become 2.5 liter. And during that course, there will be no evolution of heat energy as well as no absorption of heat energy. That means when you mix liquid A and liquid B, then during the solubilization, there will be no absorption of heat energy as well as no evolution of heat energy. No heat energy will absorb, no heat energy will evolve. And delta V mixing equal to 0 means the total volume of the resulting solution should be summation of both of the liquid. That is in ideal solution. In non-ideal solution, what happens? When you dissolve A and B, then the resulting solutions, the volume of resulting solution may be less than 2.5 liter, maybe 2.4 liter, or maybe more than 2.5 liter, maybe 2.6 liter. So that solution will be non-ideal solution. In ideal solution, during solubilization, there will be no absorption of heat energy, no evolution of heat energy, and after mixing both the liquid, the volume of resulting solution will be addition of both the liquid. That will be here delta V mixing 0, delta H mixing 0. That will be ideal solution. What is non-ideal solution? So, non-ideal solution is the solution which do not obeys Raoult's law over entire range of concentration. The solution which do not obeys Raoult's law over entire range of concentration. That is called non-ideal solution. And the non-ideal solution is of two types. One is non-ideal solution showing positive deviation, and another will be the non-ideal solution showing negative deviation. Positive deviation means the vapor pressure of liquid solution will become greater than expected from Raoult's law. When the vapor pressure of solution will be greater than expected from Raoult's law, then it will be said that the solution is non-ideal, showing a non-ideal solution showing positive deviation. In the same way, when two liquid will be mixed and the resulting vapor pressure will become lower than expected from Raoult's law, then it will be said that the solution is non-ideal solution showing negative deviation. When the vapor pressure of solution will be greater than expected from Raoult's law, then the solution will be called non-ideal solution showing positive deviation. And when the vapor pressure of the solution will be lower than expected from Raoult's law, then it will be called non-ideal solution showing negative deviation. Let's see about the example. Let's see about this one, graph. So there will be graph here. Here, this one, watch out. Here chi1 is 0 and chi2 is 1. So at this state chi1 will be 1 and chi2 will be 0. So at this one chi1 is 1. So this will be p degree 1. And here chi2 is 1. So here p degree 2 is this one. So between both of them, this is a graph, here p degree 1, this is a graph, here it is p degree 2. Now, and this one, so this dotted line has shown the vapor pressure of liquid 1 and the liquid 2 as expected from Raoult's law. As expected from Raoult's law, this dotted line represent the vapor pressure of liquid 1, liquid 2 and the P total. This one. And let's see in this graph. This graph is about here chi1 0, chi1 1. So here it will be p degree 1 and here chi2 is 1. So here it is p degree 2. And dotted line represent the vapor pressure of liquid 1, liquid 2 as well as P total. The liquid 1, liquid 2 as well as P total. But in case of non-ideal solution showing positive deviation, here that should be the partial graph of the partial vapor pressure of liquid 1. But that will be not this line, solid line. That is actually the observed vapor pressure of liquid 1. And this solid line represent the observed vapor pressure. That means this line represent the observed vapor pressure of liquid 2 and this is the observed vapor pressure of solution. So what you have seen, the partial vapor pressure of 1, partial vapor pressure of 2 as well as P total, that means total vapor pressure of solution is greater than expected from Raoult's law. So this graph is of non-ideal solution showing positive deviation. This graph is about the non-ideal solution showing positive deviation. And here in this graph, the dotted line represent the vapor pressure of liquid 1. This dotted line, the vapor pressure of liquid 2. And this is the total vapor pressure of solution as expected from Raoult's law. But it has been observed that the graph of vapor pressure of 1 is this one, which is lower than expected from Raoult's law. Here vapor pressure of liquid 2 is also lower than expected from Raoult's law, and the total vapor pressure of the solution is also lower than expected from Raoult's law. So this is the graph of non-ideal solution showing negative deviation. Okay guys, that was about ideal solution and non-ideal solution. Now in 12th board examination, question frequently asked about ageotrophs. What is ageotrophs? And oftenly, normally students don't get full marks in this question. Actually, the students don't mention all the points which they will have to write. So let's see what is ageotrophs. Ageotrophs are the solution which boils like pure liquid. Suppose here you have mixed ethanol and water. Here ethanol and water you have mixed. Here 95% ethanol you have taken, 95% ethanol and then remaining 5% water. This one by in terms of volume you have taken. So what happened at this state when you will heat them? So what is the ratio? If suppose when you will heat them, so it will get in the vapor phase and it will collected in another container. In this container also the water will be 5% and alcohol will be ethyl alcohol, that will be 95%. So by heating them you cannot separate ethanol and the water, and its boiling point will be fixed. Its boiling point will be fixed. Okay, this one, and its boiling point will be lower than 100 degrees Celsius. Its boiling point, it will be near about 98.8 degrees Celsius. So boiling point here is fixed, and that is for liquid. So ageotrophs are the solution of two liquid. Ageotrophs are the solution of two liquid which boils like a pure liquid. Ageotrophs are the solution of two liquids which boils like a pure liquid, that is possesses sharp boiling point. That is possesses sharp boiling point. Undergoing the vapor phase in the same proportion as are present in liquid phase. Here proportion of liquid and water is, here ethanol and water is 95% and 5%. Here also same 95% ethanol, 5% water. So undergo in the vapor phase in same proportion as are present in liquid phase. So this one cannot be separated through fractional distillation. So what we will have to, one marks question, write about ageotrophs or ageotropic mixture. You will have to write the solution of two liquid which boils like a pure liquid. The solution of two liquid which boils like pure liquid, that is possesses sharp boiling point. Undergo in the vapor phase in same proportion as are present in liquid phase, and hence cannot be separated through fractional distillation. So you will have to write 3 points about the ageotrophs, then you will get full marks. What you will have to write? Ageotrophs are the solution of two liquids which boils like two liquid, that is possesses sharp boiling point. Undergo in vapor phase in same proportion as are present in liquid phase, and hence cannot be separated through fractional distillation. Okay. Now, this azeotrophs is of two types, maximum boiling azeotrophs and minimum boiling azeotrophs. Maximum boiling azeotrophs and minimum boiling azeotrophs. So, as a name indicate, maximum boiling azeotrophs means boiling point will be greater than both the liquid. Maximum boiling azeotrophs means boiling point will be greater than both the liquid, and minimum boiling azeotrophs means boiling point will be lower than both the liquid. So, if boiling point will be lower, that means before that, what is boiling point? Listen. Boiling point is what? The temperature at which the vapor pressure of liquid become equal to atmospheric pressure. That is called boiling point. Boiling point is the temperature at which the vapor pressure of liquid become equal to atmospheric pressure. You already know the boiling point of water is 100 degrees Celsius. That means the boiling point of water is 100 degrees Celsius, means there is a liquid, suppose it will undergo this liquid water here. So the liquid water undergoing the vapor phase frequently. If temperature will be less, then its vapor pressure will be less. Now, when you will supply the heat energy, when you will heat this water, so more and more water particle will undergo in vapor phase. When you will supply the heat energy to this liquid water, more and more liquid water will undergo in vapor phase. So vapor pressure will increase on increasing the temperature. What happen when the temperature will become 100 degrees Celsius? When the temperature become 100 degrees Celsius, then the vapor pressure of this liquid become equal to atmospheric pressure. That is called boiling point. So boiling point is the temperature at which the vapor pressure of liquid become equal to atmospheric pressure. Okay. So maximum boiling azeotrophs and minimum boiling azeotrophs means boiling point will be lower than both the liquid, and when that means boiling point is lower, that means at lower temperature the vapor pressure of liquid become equal to atmospheric pressure. At lower temperature the vapor pressure of solution become equal to atmospheric pressure, and that is when the particles of this solution will undergo in vapor phase frequently. So, and when the vapor pressure of liquid become greater than expected from Raoult's law, that is called positive deviation. So minimum boiling azeotrophs will be the azeotrophs which shows large negative deviation from Raoult's law. So minimum boiling azeotrophs are the azeotrophs, minimum boiling azeotrophs is the azeotrophs which shows large positive deviation from Raoult's law, and hence the boiling point of resulting solution become greater than that of both the liquid. That means minimum boiling azeotrophs is the azeotrophs which shows large negative deviation, which shows large positive deviation from Raoult's law. So minimum boiling azeotrophs is the azeotrophs which shows large positive deviation from Raoult's law, example is 95% ethanol and 5% water in terms of volume, that is minimum boiling azeotrophs. Same, maximum boiling azeotrophs, that means boiling point will be greater than expected from, that means from both the liquid. That means boiling point will be greater than both the liquid component. That will be called maximum boiling azeotrophs. So here what happens? That means vapor pressure of resulting solution is lower. Vapor pressure of the solution is lower than expected from Raoult's law. That's why it is maximum boiling azeotrophs. Example here, that means the solution which shows large, here not positive deviation, here negative deviation from Raoult's law. And example is 68% nitric acid, 68% nitric acid and remaining 32% water, 32% water by mass. That is, so ideal solution is here the solution which obeys Raoult's law over entire range of concentration, and non-ideal solution is the solution which do not obey Raoult's law over entire range of concentration. Then after is the non-ideal solution was of two types. Non-ideal solution showing positive deviation. In that case, the partial vapor pressure of both the liquid as well as the total vapor pressure of solution was greater than expected from Raoult's law. And the non-ideal solution showing negative deviation. In that case, the vapor pressure of both the liquid component as well as of the resulting solution was lower than expected from Raoult's law. Next type of solution was azeotrophs. That is a special type of solution, that is azeotrophs. At a particular concentration, at a particular concentration, the solutions boils like a pure liquid. That is, that solution possesses sharp boiling point. That solutions give same composition in the vapor phase as are present in liquid phase, and that's why that type of solution could not be separated through fractional distillation. That type of solution was called azeotrophs or azeotropic solution or azeotropic mixture. Now azeotrophs was of two types. One was maximum boiling azeotrophs. In maximum boiling azeotrophs, the boiling point of resulting solution will become greater than that of both the liquid component, and in that case the vapor pressure of the resulting solution will was negative deviation. That means that solutions was showing large negative deviation from Raoult's law. That was maximum boiling azeotrophs. So in maximum boiling azeotrophs, the solutions will show large negative deviation from Raoult's law, and the boiling point of the resulting solution will be greater than that of both the liquid component. And another one was minimum boiling azeotrophs. In minimum boiling azeotrophs, the solution will show large positive deviation from Raoult's law, and that will possess the boiling point greater than that of both the liquid component. Example here is the 95% ethanol and 5% water mixture. That means solutions having 95% ethanol and 5% water by volume. And in case of minimum boiling azeotrophs, the example will be 68% nitric acid and 32% water. That means solution having 68% nitric acid and 32% water by mass. Okay, that was about the Raoult's law. Let's see about this question. This question is vapor pressure of two liquid A and B are this one and this one. That means vapor pressure of A in pure state is given, B in pure state is given. Find out composition of liquid mixture if total vapor pressure is 600 mmHg. Total vapor pressure has been also given 600 mmHg. Also find the composition of the vapor phase. So this type of question is of same type about which we have already discussed. I hope all the students who are listening my videos will be able to solve this question very frequently. That means there is nothing in this question. No stress need to be taken to solve this question, because this question is of same type about which we have already discussed. Even though whose chances is less, even though if any student we could not solve this question, may ask to me from comment box. Okay, now in the next videos we will study about colligative properties and determination of molar mass. First of all, what is colligative properties? The properties which only depend on the relative number of moles of solute and do not depend on the nature of solute or solvent particles. That is called colligative properties. Those properties of solution which only depend on the relative number of moles of solute particle and do not depend on the nature of solute particle or the solvent particle. That type of properties is called colligative properties. This colligative properties is of four types. Number one, here relative lowering of vapor pressure. In the same way, there will be one is relative lowering of vapor pressure. Second one will be elevation in boiling point. Elevation in boiling point. One is relative lowering of vapor pressure. Number two will be elevation in boiling point. Elevation in boiling point. Number three will be depression in freezing point. Depression in freezing point. And fourth one will be osmosis, about which we will discuss in detail in the next video. But just like in summarized form, I tell you what is that. Guys, boiling point here, elevation in boiling point. Because about the boiling point, I have already informed you what is that. So boiling point is the temperature at which the vapor pressure of liquid become equal to atmospheric pressure. That will be called boiling point. So water, boiling point of water is 100 degrees Celsius. The boiling point of water is 100 degrees Celsius. When you will dissolve salt or the sugar in the solution, that means when you will dissolve any solid in the water, the boiling point will increase. There will be increment in the boiling point of the solution. So boiling point will elevate. So when you will dissolve any solid in a liquid, its boiling point will increase. Their freezing point will decrease. Like that, the freezing point of water is 0 degrees Celsius. So when you will dissolve any solid in a liquid, then water will freeze at temperature lower than 0 degrees Celsius. Maybe at -1 degree Celsius, -2 degree Celsius, or any other temperature lower than 0 degree Celsius. Osmosis is what? Osmosis is the movement of solvent particle from low concentration to high concentration through semi-permeable membrane. Like here is a container, this one. In this container there is a liquid, and another case here there is another component, there is solvent. Suppose here it's solvent and it is solution, both connected through this one, and here is a semi-permeable membrane. Usually goat's urinary bladder taken or Parkman membrane taken as semi-permeable membrane. It is semi-permeable membrane. So what happened? Solvent particles moves from this pure state to this solution. This phenomena is called osmosis. So osmosis is the movement of solvent particle from pure state to the solution through semi-permeable membrane. Okay, in the 12th board examination, that is the frequently asked question is about osmosis. So osmosis is the movement of solvent particle from pure state to the solution through semi-permeable membrane. About this one, relative lowering of vapor pressure. That means when a solid will dissolve in a liquid, the vapor pressure of resulting solution will decrease. What will be the relationship between the concentration and the relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmosis? About that one we will discuss in the next class. It's all for the today class. Thank you, Team Educate.